Okay, welcome back to our statistics class notes. We're on page 63 in section 5.2 where we're talking about probability. So a couple more definitions that I need you to understand before we give some probability rules are sample space and events for equally likely outcomes. So a sample space is the following. It's the set of all possible equally likely outcomes of an experiment. And the event is any event is any collection of outcomes in the sample space. So example 82, let's find the sample space for rolling a fair die. So hopefully everyone's rolled a die, but there are 6 sides and there's dots on each side, right? 1, 2, 3, 4, 5, 6. So when I roll a die, that's all possible outcomes. You can get a 1, a 2, a 3, a 4, a 5, or 6, and we call that S for sample space. Capital S equals the sample space. Now, what are the outcomes for event A, where if I tell you that event A is rolling an odd number? So the outcomes for A then would be either getting a 1, 3, or 5. So those are the outcomes you can get for rolling an odd number. What are the outcomes for event B, where you're rolling number less than 4? So that means we don't want 4, we want numbers less than 4. So you can get a 1, a 2, a 3 when you roll a fair die. So the outcomes for event B are 1, 2, 3. Using a sample space to find a theoretical probability. So let's do another example here. For example, 83. A family has 2 children. Let's find the probability of event A that they have 1 boy and 1 girl. Now somebody answering this quickly might think it's 33% chance or a 1/3 chance, right? 2 children and we want to find the probability that they have 1 boy and 1 girl. So when you think through it though carefully, it's not that. So let's see how. So let's let B equal boy, G equal girl. Okay? So then the sample space is that family could have a boy first and then another boy, or they could have a boy first then another girl, or they could have a girl first and then another boy, or they could have a girl first and then another girl. So there's 4 possible outcomes to having 2 children. So the event A, which is having 1 boy and 1 girl, includes the outcomes boy, girl, and girl, boy. Okay? So how do I find the probability of event A? The way you do it, this is our first rule. This is the general probability rule. You find the number of outcomes in the event that you're talking about, and you divide that by the number of outcomes in the entire sample space. So there are 2 outcomes in A, right? You could have either a boy, girl, or a girl, boy to get both 1 boy and 1 girl. And then the number of outcomes in the entire sample space, the way you could have 2 children, there was 4 different outcomes. Boy, 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 girl, girl, boy, girl, girl. So 2 out of 4 is the same as 1 out of 2, or a 50% chance of having both a boy and a girl. Now, we got to start to get precise with our words. So when I'm combining events with and, so an outcome belonging to A and B, event A and B, must belong to both A and B. If I'm combining events with the word or, an outcome belonging to A or B must belong to A or B, or it could be in both. Okay, it's A or B. All right, example 84, playing cards. Okay, so I'm going to run through this entire example even though it starts on the next page. So playing cards. There are 4 suits: clubs, diamonds, hearts, and spades. So hopefully everyone understands playing cards and has played with them before. And the following cards appear in each suit. You have an ace, then you have a 2, 3, 4, 5, 6, 7, 8, 9, 10, and then you have a jack, a queen, and a king, all in those suits. So there are 13 cards in each suit, makes for a total of 52 cards in the deck. The jack, the queen, and the king are called face cards because they have a drawing of a face on them. Diamonds and hearts are red. Clubs and spades are black. If you draw 1 card randomly from a standard 52 card playing deck, what is the probability that it will be a club? So there are 13 cards with clubs on them out of the 52 playing cards, or you can think of it as 1 out of the 4 suits, but that would reduce to 1 out of 4. What's the probability of getting a black card? Well, half the deck is black and half the deck is red because you get 2 suits are black and 2 suits are red. So a black card would be 26 out of 52, or 1/2. Think of it that way. What about a red 10? Well, there are 2 red 10s, right? The diamond of the 10 of diamonds and the 10 of hearts. So 2 out of the total 52, which is 1 out of 26. What's the probability of getting a face card? A jack, a queen, or a king? So there are 3 face cards in each suit, and there are 4 suits. So there are 12 total face cards out of 52, or there are 3 out of 13. You could have thought it as in one suit, but that reduces to 3 out of 13. What about an ace? Well, there are 4 aces in the deck out of the 52 cards, so that's 1 out of 13. And if one card is selected, what is the probability that the card will be a spade, or a heart, or a diamond? So how many spades, hearts, and diamonds are there? Well, there's 13 spades, 13 hearts, and 13 diamonds out of the total number of 52 cards, which is 39 out of 52, or 3/4. And you could think of it as 3 suits out of 4 represented, right? So either way, I'll stop there.